rational number. Let's look at irrational numbers. This is very important. Very, very important. So we're going to be looking at what is irrational numbers, examples, basic operation, and some properties. Let's begin. What is irrational number? Let me give you a very quick definition. Irrational numbers, these are numbers that cannot be written. Listen, that cannot be written as the ratio of two integers. Cannot be written as ratio. You know ratio? Remember ratio? Ratio means something by something, right? Something by something, right? So it cannot be written in this form. Okay. Now, what are examples of irrational numbers? What are examples? Let me give you the summary of examples. We have a lot of them. So, some of the examples of irrational numbers, this is called pi. Pi is a Greek language. Pi, P-I. Pi is approximately to be 3.1415. You can use 3.14. Yes, 3.14 approximately. Exponents. This is exponential, and exponential is approximately at 2.72. Radical numbers. Anything called radical are irrational. Anything radical are called irrational. So the roots of 2, root of 3, root of 5, root of 11, root of 13, like that. Any number that if the root of 4 is 2 rational number, because root of 4 is 2. So be careful. So anything that you cannot find proper results, proper whole number, it's called irrational. So which means the roots or radical number of prime number are irrational. Remember prime number? You see connectivity of mathematics is very important. So we have a lot of them. This is some of them, a lot of them. Now let's see how we can operate with them. Okay, so now let's look at basic operation of irrational numbers. We have addition, subtraction, multiplication. We know this. Okay, let's start. Pi plus 4 pi. Don't forget, there is 1 here. It's like 1 pi plus 4 pi. So this is pi, they are in common. So you can say 1 plus 4, 1 plus 4 of pi, because they are both pi. So we can say the answer of this is what? 5 pi. You see? Very easy. Pi plus 4 pi is 5 pi. Radical 7 plus radical number 7. Or say root 7 plus root 7. Root 7 is common. What is here is 1. When nothing is written, it means that it's 1. So 1 is here, 1 is here. So what you have to do is 1 of this place plus 1 of this place, everything we are in 1 root. So 1 plus 1 will give us 2. So we have 2 root 7. Please be careful. There is this difference between 2 root 7 and 2 of 7. Be careful. This one is. This means 2 times root 7. This means square root of 7. Yes. Be careful of this one. Okay? Now, root 3 plus root 5. They are not agreeing. Right? 3 is here, 5 is here. So they do not agree. And it's addition. So there is nothing to do here. So the answer to this one is still the same. Root 3 plus root 5. Why? Because we are not in the same terms. So we can say it's unsolvable because they are not agreeing. Let's look at this one. Now, look at this one. Root 2 plus root 5. Root 8. Also, they are not agreeing. But 8 can be broken down. we can break it down. Using our tree diagram we learned before, we know that 8 can be divided into different parts. So we have 4, 2, 2, 2, 1. So 8 can be rewritten as root 2 plus root 2 times 2 times 2. Root 8 can give us this. You see, this one is not possible to break them down. It's already prime number, it's already prime number. But this one is not prime number. So, root 2, I mean, 2 times 2 times 2 is 8. So we can say root 2 plus 2 times 2 is what? 4. So we can say root 4 times root 2. I break it down. Do you understand? Why will I break it down? Because I know that root 4 is perfect root. I want to keep it outside. Are we together? Are we together? This is very important. This guy is a perfect root, so I multiply these two. Keep it outside. So root 4 will give me 2. So I have root 2 plus 2 times root 2. Do you understand what I did? What I did here is simply that 2 times 2 is 4. And I know that 4 is a perfect root. So I keep it outside. So root 4 times, if you want, maybe it's a little confusing. Let me put this one in one root. Okay, so 2 times 2 is 4 times 2. Root of 4 is 2. So it's out. This one has no square root again. 2 times root 2. Are we together? Now it's easy for me to operate that this is 1 root 2 plus 2 root 2. So I can add this 1 plus this 2, and we have 3. And then since it's common, I pick 1. And this is the answer. Please be careful. This and this cannot be break down, but this can be broken. Okay? So multiplication can work together with different kind of roots because it's multiplication. Now, let's look at, you can check it again. Let's look at subtraction. Root 3 minus root 3. What is here? Is 1. What is here? Is 1. So 1 minus 1, root 3. 1 minus 1 is what? Is 0. Is 0 root 3. 0 times root 3 is 0. I know it's there. So this is wrong. It is no more a rational number. The 0 is not a rational number. 0 is whole number. 0 is not a natural number. Right? It's an whole number. So we'll come from irrational to whole. These are some of the properties of irrational. Now look at this one. 9 root 2 minus 4 root 2. Root 2, root 2. So they agree. They are in the same root. So we can operate them together. So we can say 9 minus 4. And now pick one root because they agree. Just like what we did. So that was the time. 9 minus 4 will give us 5 times 2. The operation of fraction. The same thing here. This is root 20. This is root 5. They did not agree. 5 has reached the last number. But 20 can still be simplified. Simplify means break it down. So 20 can be break down. Just like what we did here. So 20. 2 can go. 10. 2 can go. 5, 5, 1. So we can say 20. This is just one side, right? But it's very important. So this is what? 7 root 2 times 2, so I can say 4 times 5 minus root 5. See? 4 again. 4 is a perfect root. So we can break it out. Take it out of the root. So root 4, I can rewrite this guy, if you permit me, I can write 7 roots 4 times root 5. If you permit me, I can do this. Right? Minus root 5. So without saying, root of 4 is 2. So we have to multiply 2 by 7. Because 7 is odd number, this is odd number. So we have 7 by 2 by 5 minus root 5. 7 by 2 is 14. Root 5 minus root 5. This is 14. What is here is what? 1. Good. I told you that if nothing is written there, it means 1. So 1 is multiplying with 5. So we have 14 minus 1, we have 13. Root 5 with 5 is common. I pick 1. You see, we are getting more serious now, right? We are getting more serious now. So be careful. I think this average is prime number. There's something you can do. That's what I do here. Now, multiplication. Multiplication, whether they are in the same root or they are not in the same root, multiplication have power to put them together. Addition and subtraction do not have power to put different roots together. But multiplication and even division, they have power. You have to respect the master. Okay, let's look at this. Pi times pi. Pi times pi. You have to remember index, exponents. This pi is having 1. This pi is having 1. Pi is common. I can pick 10 pi. So 1 here plus 1. Remember, index, we did this. We did it before. You can check our previous video. So now 1 plus 1 will give us 2. So the result is pi squared. Pi squared. Now this place. This is multiplication. Since this is root, square root. If it's cube root, it doesn't work. But this is square root. Since this is square root, this is square, you can put them in more. That is the power this guy have over this. So you can say the root 2 times 8. That is the power. But this guy cannot do this. And this guy cannot do this. So 2 times 8 is what? 16. And 16 is a perfect root. Right? 16 is perfect root. What is the root of 16? 4 is the root of 16. Square. Square. We have cube root also. So there's that quite good. But I don't want to go too deep there now. We are going to see it more in the future. Now look at this. We are multiplying 7 radical 2 times pi. Pi did not have any root, no square on top. So which means we only have family with this guy. You have no business with this guy. But this one is a root. This one did not have root, this one did not have root. The one that did not have root, you can put them together. So you can say 7 times 5 times root 2. This guy and this guy is the same thing. Yes, same. Now I can say 7 times pi will give me 7 pi times 2. C'est fini. Finito. You speak Italian? Parco Italiano? Remind me, that was I learned some years ago. Okay. So, do you understand? I hope you are following. This one have root, this one do not have root. So, you have to go and make the one that don't have root. Yeah, the one that don't have root. Put them. The one that have root. Now look at this one. There's no root here. Oh, this one is more easier. So, we have one exponent plus 2 exponent times 1 exponent. Don't forget, there is power here, there is power here, there is power here, but the power is what? 1. So we can say 1 times 2 times 1, we have 2. Exponent, exponent, exponent. You can take only one exponent, right? So we have 1 here, we have 1 here, we have 1 here. So we have 3 exponents here, so we have 2 exponents. Don't forget, the value of pi is 3.14. We're not supposed to do it. Okay. I don't want to start multiplying decimal number. So it's 1 plus 1 plus 1. So we have 2 exponents. Exponent is 2.7 something, right? Don't do it. This is the now, come here. Root 2 divided. Now, division. Root 2. Root. Just like this guy. I can put them in one root. So I will have this guy as the square root of 2 divided by 8. It is possible. Yes, it's possible. So, this guy is the same thing as the roots of 2 by 8. We express as what? 2 times 2 times 2. So I can say 2 times 2 times 2. The space is 1. 1, 2. Can cancel 1, 2. So what is left here is 1. 2 times 2, 4. So what is the square root of 1? It's 1. The square root, this one is seen as root 1 by root 4. So don't let me jump step, right? I can break it root 1 by root 4. Now, what is square root of 1? 1. What is square root of 4? It's 2. So the final answer is 1 over 2. It's interesting, right? Okay. This one, exponent divided by pi. So this is guy, it's an exponent by pi. Anything cancel anything? Nothing. Finish. I told you we have value. Exponent means 2.7 something. Pi means 3.14. Leave it. Just leave it as it. Okay. If I say, take pi to be this, it to be this. Now it can be. For now, just leave it. It's finished. Nothing can cancel. Come here. Division again. 15 pi by 3 pi. What I want to pi? Pi cancel. Pi is gone. 3 goes here, 1. 3 goes here, 5. What goes here? 3. So what is left here is 5. What left here is 1. So 5 by 1 will give us 5. 5 by 1 will give us 5. So we move from irrational to whole number. Also, it's called natural number. Right? We are almost done. Next question. Root 6 by 2 pi. Root 6. This one is having root, but this one is not have root. Be careful. You cannot put them together. I know we are thinking that 2 will cancel this. Don't try it. Because they are not in the same umbrella. Okay? So we cannot divide this by this. Because this one have root and this one does not have root. So just stop. Assuming this one have root now. You can say you keep them in one root. I hope you're getting this. These are simple mathematics that is very, very important. Okay, good. This one is comprehensive addition and then multiplication. Multiplication. So let's multiply. This guy times this guy, this guy times this guy. So let us first open the bracket first. So we have 2 root 3 times 6 root 3 plus 2 root 3 times 4 root 3. I think the pen is feeling hungry. Okay, now don't forget you multiply the one that have no root together and the one that have root together. 2 they don't have root. 6 they don't have root. You can put them together. So 2 times 6 will give us what? 12. Root 3 times root 3. They are the same root. So I can put them in one root. So I will say root 3 times root 3 is root 9. Right? Plus 2. Okay, let me multiply. Just the same opposite time. 2 times 4 is 8. Root 3 times root 3 is root 9. Now, the question is that root 9 is a perfect root. Root 9 is what? Is 3. So I can say 12 by 3 plus 8 by 3. No more roots. No more radical number. So 12 times 3 is 36 plus 8 times 3 is 24. Now 36 plus 24 will give us 60. Radical to natural. The last but not the least. Roots. 6 root 2 plus 4 root 2. This is plus. We are lucky here because this is root 2. This is root 2. So we can choose, we can pick one. So I can write this guy, solve this one, and later put them together. So this and this is having the same root. I can say 6 plus 4 will give me 10 root 2. Root 2 divided by 2 root 2. Root 2. Now I can take my scissors. 2 goes here 5 times. 2 goes here 1. The one that did not have fruit, operate them. The one that have fruit, operate them. This root 2 cancel this root 2. So what is left? 5. Only 5 left here. Only 1 left here. 5 by 1 is the final answer is 5. So we move from radical to whole number. It's not every time we're going to get this, of course. Sometimes you can move from radical. You can move from irrational, to irrational. Irrational to irrational. Irrational to again irrational. Irrational to whole number. Irrational, whole number. Or natural number. Irrational to whole number. Or if I call it fractional number. This is fractional. Right? Fractional number. Irrational, whole number. Okay.